This video is brought to you by BlueCert. BlueCert is a trusted provider for AI-related certifications designed to validate expertise in machine learning, data science, NLP, AI security, and more. You can go to bluecert.org to take a look at all of their offerings. You can explore the certifications. Here we have certifications on machine learning, AI healthcare, AI in finance, natural language processing, and many more. If I go to machine learning, you can see the different potential roles that are available for machine learning as developers and even different paths that are available. And this provides you with AI-focused specialization, flexible online exams, and also employer recognition. You can also check out some of the sample multiple choice questions on that category. If you're looking for certification for machine learning or AI related fields, check out bluecert.org. Hello everyone, and I'm excited to present this real-world project of predicting car prices using the Carvana dataset. Now there are a lot of different ways that you can actually get started. You can install mini Conda, and then you'll have to create an environment with Pandas and Matplotlib and NumPy, Scikit-learn, all of those things. But I always recommend to check out Google Colab because all of that stuff, including the Jupyter Notebook, is already installed. All right. So I'll be using Google Colab for this particular project. But if you want to set up your own environment, you can. But I recommend that just to play around with data, just to play around with the APIs, check out Google Colab because that is what I'll be using. And it already has all the tools and packages that I need already installed. So I can just get a head start and start training my models. As I mentioned previously, that you can either set up the Conda, mini Conda environment on your machine, or if you just want to see it working, you can simply go to Google Colab. So Google Colab it allows you to write your Python code and do the same exact things that you can do on your local machine, but it is hosted on Google. And the good thing about Google Colab is that you can create these notebooks. So just like you can create notebooks on your, on your own computer, you can create these notebooks on Google Colab. And every notebook that you're going to create, it will automatically have Pandas, and it will have, Matplotlib and Scikit-learn and TensorFlow. So all of those libraries, the most common libraries will already be there. So that's a great way to get started and to just experiment and create models for any data set. So I'm going to just go ahead and say new notebook. Now keep in mind that these notebooks are created on Google Colab server, but you can always go ahead and download the notebook if you want to. Let's change this name. So I'm going to go ahead and say predict car prices. Okay, that's a nice name for the notebook. And the other thing that I want to do is I want to, first of all, let me make sure that I'm on the correct one. Okay, got it. Let's go ahead and, zoom in a little bit so that you can see it nice and clear. So this is our notebook, and you can write any commands over here. Like if I go ahead and say over here, A equals to 10. If I want to run it, I'll just say Shift and Enter, and it will run this particular line. And I can also output A. Now, the first time you run, it is going to take a little bit of time, but now if I run, it should be really fast. So now I can run this square, and you can see that how it's working. All right. Okay. So the first thing we need to do is to get access to the Carvana dataset. I'm going to go ahead and open a new tab and go to Kaggle. Kaggle is a website where you can download data sets, you can check out the code, the discussion articles. They also have host competitions. We're mostly interested in the data set. And make sure that you're logged in. It's free, so make sure that you log in. I can go to data sets, and over here I can search for the data set that I'm looking for. Now I have already search for Carvana dataset, so that's why it's actually appearing right there on my work. But I can search for it, or I can simply say Carvana, and it should come up. Carvana predict car prices. You can actually use any data set that you want. So if I go to this data set, we can see over here that this data set contains 22,000 rows. Wow, that's a good amount of rows. All right. And you can also see that it has 4 different columns, 4 different features. We have the name of the car, we have the year of the car, we have the miles of the car, and we have obviously the price of the car, because that's the important column, the target column. That's what we want to find out, the price of the car, which will be based on the name, year, and miles. So now I can go ahead and download it. Here's the download button. Now all of this data is in a CSV format, so it's not really going to be too big. Even though it's 22,000 rows, we can just download it as a zip file, and you can see it's like 137 kilobytes. So let's go ahead and download it. You can just click on this download dataset as zip file. It's 137 kilobytes, so it's pretty small. Let's go ahead and unzip that. Okay, and there it is. Now I'm on Mac, so I can actually use Numbers or any other program to open it. But if you are on a Windows machine, you can use Excel spreadsheet or whichever program that you want to open. And as expected, we can see, and look at the scroll bar over there. I mean, it's a lot of data, 22,000 records. All right, so that's good. We have access to the record. Now we're currently using Google Colab. This means that somehow we need to upload the file, the Carvana CSV file, over here, like in the predict car prices or Google Colab, so we can use it. There are multiple ways of doing that. If I click on this folder, you can see that the sample data, so there is some sample data that's already available. So that's a good thing about Google Colab, is that you can just play around with this data. You have California housing prices, training and testing data. You can use that. Or, this is, I think, the numbers data. So you can play around with these things. But we want our own data. So I'm just going to go ahead and click and upload our file, which is coming from Carvana, this one. And it's a small file, so it's not going to take that long. You can see that it is already uploaded. Now keep in mind, and that's very important, that the files that you put in the sample data, your files especially, which is carvana.csv, the next time you're going to run or access your predict car prices, this file will be removed. So if you want to persist that file, you have to attach it to Google Drive. All right. I'm not going to do that because my Google Drive is already too big, so it's going to take some time. But if you simply mount your Google Drive and you put the CSV file in the Google Drive, then you can always access it, no problems. All right. All right, so we have the file. I can actually click on these and then get a path to the file. And now I can kind of like go back to our code. Let's see over here. I think this is our code, so we'll just go back over here. The first thing we need to do is to import Pandas and start looking into the file. So I'll say import pandas as pd, pd.read CSV, because it's a CSV file. And we already have the path, so I'm just going to provide the path, and we'll get the data frame. So Pandas is going to allow us to read the file, and then it's going to, when we call the read CSV, it's going to give us a data frame, which is kind of like an in-memory representation of the tabular data that it has read. So I can go ahead and display that. I can say df, which will just display the content of the file. Now obviously it's not going to show you all the contents, but you can see that it's showing us the first 5 and the last 5, and it will give us a little bit idea of what's going on. If you want to display only the first 5, you can also say df.head and shift enter to run it. Okay. Now looking at the data, everything looks fine, but let's look a little bit closer to the data. We have the name column. That is name. Okay, different cars. You have Jeep Wrangler, Jeep Renegade, BMW. That's fine. We have the year column, and that's weird, right? I mean, 2018 is good. This is good. This one looks kind of weird. Look at the year over here. 20173. That's kind of weird. I mean, we cannot really have years that are, 20173. That is far, far, far in the future, right? So I do wonder that how many years are there? Is it like only one of them that is 20173 or 20 whatever? Or are there more of these things? And we can actually find this out by saying the data frame. And over here, we can put some sort of a condition. So we can say that, okay, give us everything which is, or the data frame which has the DF year column greater than 2025. All right. If I run this, I find out that it's not only one instance where it was 20173. We have tons of these things. I mean, how many rows do we have? We have 2,851 rows out of 22,000. Now that is a lot, right? So this is where we have to clean the data. This is where we have to process the data. We have to clean the data because we can't really provide these dates. These dates are all wrong. And if you don't clean up the data, if you don't fix these dates, then, well, nothing will work correctly, right? Because the machine learning model will be trained on these dates, and these dates don't really exist in real life. If you look closely, we can figure out that maybe the person who was typing in or something bad happened, but maybe they were actually only trying to take these 4 numbers, right? I mean, maybe we can do that. Maybe we can take or extract out the first 4 numbers, which will make it, well, correct. But how do we do that? Now, it may look complicated, but when you're using, pandas and data frames, it becomes a little bit easy. So let me show you. So what we're doing is we're going to say df, which is our data frame, give me the year column. Now, if I simply say give me the year column, you can see that I get only the year column. All right. Don't worry too much about these numbers on the right hand or the left hand side, because this is just, Google Colab and Jupyter Notebook, just giving you some IDs or indexes, which are not really part of the data frame, but they're just going to help you out. All right. But the actual data is the one with the column name, year. And you can see that we are getting only the column year. Okay. So what we can do with that? Well, if we want to select only the 4 first from left to right, and this is the integer column, by the way, right? So what we can do is we can try to convert this as type to string, okay? And once we convert it to string, then, now it's already converted to string, then we can take the first 4 characters, first 4 letters, and once we take that, so at this point, let me show you what happens. So this is 20173, right? So it's going to convert it to string. So it's going to become 20173. We are probably over here when we are doing that. The next, we're going to use a string function and take only the 4 characters. That will give us still a string, 2017. But we need to convert it to integer also, because machine learning algorithms, they work really nice when you are using integers. So all of these, characters or all of these strings, 2017, needs to be converted into integer, which is not a big deal because we can again call as type integer. All right. So what will happen is that when we call that, it becomes 2017 as an integer. See, I'm not putting double quotes around it. So it's indicating that this is an integer now. Now, it is going to return us the whole, basically the series for the year that's converted, all right, that's fixed. And what we can do is we can assign it back to the year column. So that's kind of cool that you can do that. We can assign it back to the year column. And now if I assign it back to the year column, and after that I look at my data frame, look at the year column over here. It's all of this has been fixed. You see that? So BMW was 20173, it's fixed. And we can even go over here on the top and try to run this line just to make sure that all of the columns are fixed. And you can see that now if we say that, hey, give us the, all the data set or the data frame where the year column is greater than 2025, it's not going to come up with anything because we fixed it. So that is our first thing that we have done. The next thing that we should look at is the miles column. Now, just by looking at the miles column, it looks fine. I mean, cars have different miles, and some of them have 41,000 miles, some of them have 98,000 miles, and so on. So what's the big deal with that? Well, let's first find out that if I say miles, it's obviously going to give me only the miles column. Let's call the max function. The max function is going to give us the maximum value in miles, or in the miles column, which is 120,000 miles. Okay, so that's one of the car has been driven 120,000 miles. We can also, just like this, do the min column, or the min function. The min function is giving us 53, which means that there might be some cars that are driven 53 miles. That's pretty low, So we can see that one car is 53, and then there's a huge gap. I mean, this is obviously the minimum. And there are other things in between, but the other one is 120,000 miles. Now, this is a lot of distance between them. I'm not really going to put all the dots over here because it's going to be a lot. But the distance between 53, which is the minimum, and 120,000 miles is a pretty big difference. And what happens is that if we don't minimize this difference, then the machine learning algorithm, let's say linear regression, if we're going to choose that, it's going to look at it and it's going to say, oh, this one is 120,000 miles. So this has to be better than 53 because it's a bigger number. So the playing field is, it's not balanced, right? Because some cars will have 53 miles, some cars have 44 miles, some cars have some other miles, 98,000 miles. So what we want to do is we want to standardize these things. Standardize means we want to get the mileage closer to each other so they all get the kind of like the same priority. So this process is known as standardization. And the good thing is that we can actually use Scikit-learn, which is a Scikit-learn, to perform standardization. And since we're using Google Colab, Scikit-learn is already part of Google Colab, so we don't really need to install anything. We just want to go ahead and use Scikit-learn preprocessing import standard scalar. All right. So that's something that we're going to import. Now from there, we can actually create standard scalar instance. So now we have an instance, an object of standard scalar. And now we will standardize the miles column. Let me type it in like this because miles is uppercase. So we'll say scalar dot fit transform. So the function is fit transform. And then we can pass in the column or columns, if whatever you want to perform. Now this will be an array, so I'm just going to go ahead and pass it like this. There we go. Now if I want to standardize other columns also over here, I can actually pass in, but we don't really need to do anything with year column or any other column right now. The miles column is the one where the difference is a lot. I mean, 53 and 120,000, that's a pretty big difference between the two. So this is going to give us standardized column, and standardization depends on the mean and the standard deviation. All right, so that will be the formula for that. And we will reassign it back to miles, right? So just like that. Now, if you want to, find a little bit more about, if you're interested in what will be the formula for standardization, let me show you. And the easiest way is to just go to ChatGPT. All right, so I'll go to ChatGPT. I'll say, what is standardization formula in machine learning? And you'll find out that this is finding the mean and then dividing it by standard deviation. All right, so we have the original value, you can see right there, original value, minus the mean of the feature. So mean basically means it's kind of like the middle point, the average. So we're going to find that, or not the middle point, but the average. So we're going to find that. And this is the standard deviation. So it's divided by standard deviation, and we get the standardized value, this one. All right, now Scikit-learn, as you can see, it already has that feature, which they're actually showing you right there. All right. Let's go ahead and run it. Now if I print out df again, we can see the miles column, and you can see that all of these values are now standardized. And now they're very close to each other. So it's not like one of them is 53 and the other one is like 120,000, because that will be a big difference, right? Now at this point we might be wondering, hold on, so we did the miles column, we did the standardization. What about the year column? Should we standardize the year column also? You can definitely try, but the difference between these years is not that much, right? I mean, the minimum year might be like 2012, and the maximum might be 2023 or 22. So it's not that much of a difference as compared to miles, where we can see that the difference was 53 and then 120,000. So that was a big difference. All right. So this is pretty good. We're able to solve that problem also. Next, let's take a look at the name column. Now, you might be wondering, hey, what's wrong with the name column? Name looks okay, right? Well, name column is a string column, and machine learning algorithms don't really work well on string values. So somehow we need to convert this into a numbers column. All right. So how can we do that? Well, there are many different ways that we can do that. One of the ways that you can do that is by using, one-hot encoding. All right. So what exactly is one-hot encoding? Well, one-hot encoding means that you see these car names over here, the name of the car. We're going to go ahead and add another column, well, a lot of column. So for every single unique car name, we are going to add a column. And let's say that column, actually, let me redraw it again. Probably I should draw it right here. Okay, there we go. So what's the name of the car? Chevrolet Trax. So I'm just going to write Chevrolet Trax. All right, Trax. And this column is the one-hot encoding column, which means that one of the values in this column will be 1 for wherever it sees Chevrolet Trax. So wherever you see Chevrolet Trax, it will be 1. And for other things, it will be 0, as you can see. Now, how many unique car names there are? I mean, in this case, we have actually a lot of unique car names, because we have close to like maybe 200 cars over here. So next one will be, let's say that if I type something else, let's say Honda, all right? Honda Accord. All right. So is this Honda Accord? No. Is this Honda Accord? No. No, no. Right there. See that? Right there. If we do it, there we go. That's the Honda Accord. So wherever it is Honda Accord, that particular value becomes 1 and all the other 200 so values become 0. Now this means that we are going to be creating a lot of these columns for every single car name. And wherever the value will be 1, then the machine learning algorithm can find out that, oh, so this particular value, like from here, let me actually remove that. From here, since the Honda Accord is 1, well, this car we're talking about is Honda Accord, all right? And if we're looking at this value, then, Chevrolet Trax is 1, then we can say, oh, it's a Chevrolet Trax. And we will eventually remove this column because the string values, they're not really going to provide us any good, and machine learning algorithm is not really going to understand that. So that is known as one-hot encoding. Our next step is to see that how we can perform one-hot encoding, how we can create those like 200 columns. I mean, that looks like a lot of work, right? But luckily, when we are using Scikit-learn, you can actually create those one-hot encoded columns rather easily. So let's go ahead and see how we can do that. So I'm going to start with calling Pandas. All right, so Pandas is actually going to allow us, and Scikit-learn is going to allow us to use linear regression, but Pandas does have a function get dummies because it's going to create dummy columns for us. And we can pass in df, which is our data frame, name. Name basically over here means that we are going to be creating, or this column will have the dummy columns, all right? And let's put it into name underscore dummies. And I'm going to just push it next line, and I'm going to say over here, one hot encoding the name column. All right, now keeping in mind that this particular data set does have like 200 different name columns. So we may have to come up with a different approach or maybe a completely different algorithm, but we're just trying it out to see that if we can actually create these one-hot encoded columns. Let's go ahead and take a look at this name underscore dummies. Look at that. See that? Now these are the names of all the cars, and it just goes on for a long time because you have so many different cars. I think like 200 or 300 different cars in the 22,000 records. So you can see that over here you can see data which is for this one. You can see this one. All of them are false, but there is one true. I mean, there has to be one true in there, all right? Because when you're creating these columns, it's a one-hot encoding. So wherever it found the name Acura ILX, then it put a 1 in there, all right? So that's the good thing about one-hot encoding, all right? You can't see over here because somewhere in the middle, but one of the columns is actually 1, all right? Now, if we look at our data frame, right, data frame still does have the name column. So what we want to do is we want to attach all of these columns, name underscore dummies, all of these columns, like 200 columns or whatever. We want to attach these columns into our data frame. So I'm going to say PD, which is again pandas dot concat. Concat means concatenate. And we're going to concatenate into df, will be concatenated with name dummies. Axis 1, because it's basically we're saying column, not the rows. And whatever it returns, let's assign it back to df. Let's go ahead and print out df again, which is our data frame. Now you can see this is our data frame. I mean, it looks kind of crazy now, right? Because we have added all of those one-hot encoded columns. So these were our columns, which are still there. But after that, all of these columns, they are one-hot encoded columns. Now keep in mind, when you add a one-hot encoded column for the name column, there's no real need for the name column to be there. So I'm going to go ahead and start dropping the name column. So df.drop the name column. So just say name column. Axis equals to 1 because it's a column. And we can also say in place. In place means that it's not going to return anything. It's just going to drop the column and update the data frame. All right. Done. Let's go ahead and print out df again. And now our data frame is looking nicer. You can see that we have the year column, we have the miles column, we have the price column. That's a column, that's a target column, and we have all of these dummy columns that we have. All right. So it's looking really nice now. Now the next thing that we want to do is we want to separate out all of these things in such a way that we have the features and we have the target that we're trying to find out. And you can do that by saying x equals to df. Now, why am I using x over here? Well, we use x because there's x and y. When you are talking about linear regression, the formula for linear regression is y equals to mx plus b, and x is the feature, y is the target value. So y is basically the price, the price that we want to find out. X is the feature, b is the y-intercept, and m is the slope. All right. So m and b, these things can be calculated. We just plug in the x value, and in this case we have multiple x values, so it will be x1 and x2 and x3 for every single feature. So the year is x1, and miles can be x2, and then the name column will be x3. Now in this case, if I simply say x equals to df and I run this, well, that doesn't really do much because x is all the things, which is good, but x should not be the price column because x should be the independent variables. All right, x should be all the features basically, which in this case is the year column, the miles column, and all of these columns. These are x, the features. Y should be the target column. So how do we do that? Well, over here we can simply say df price. So y is easy, right? Because we can simply say y should be the price column. X should be all the other columns except the price column. So what we can do is we can say df.drop, drop the name of the column. The column will be price, and axis equals to 1. And since I'm not putting in place true, this means that the drop is going to return a new data frame, which we will assign it to x. So now if I go ahead and probably run this again, and run this again, and you can see now if I run, you can see the x over here. This looks pretty nice because it has a year column, it has a miles column, the price column is gone, the name column is replaced by all of these, which are one-hot encoded values. Keep in mind that in this column and in every single column for the car name, there is one row that is 1. All right, so keep that in mind. And if I simply say y, well, you can see it's the price column. That's the target column. All right, so we didn't really change anything. We just have the target column over here. Now the question comes, well, how do we train it? Train the model. We have done a lot of work to prepare the data, to process the data, but we haven't really trained the model. So now we are ready to train, because looking at this, we can see that all of the things in our data set or data frame, they're all numbers or Boolean values. I mean, even the Acura or all these things, these are either 1 or 0. So we are good to go on that part. All right. So the next part will be training the model. How do we train the model? So in order to train, we have to use a particular algorithm. And one of those algorithms, the most common algorithm to predict the car prices or predict these kind of, the values for numerical values, regression algorithms, is linear regression. So we can actually import that. So we can say sklearn, again it's scikit-learn, dot linear model and import linear regression. So we're going to import linear regression, which is a algorithm that can be used to predict, values, running values, like car prices, home prices, these kind of things. And we are also going to import a couple of other things, which is sklearn dot model selection import train test split. So train test split is a function that we're importing, and it is going to allow us to split our data into training set and testing set. We're also going to import sklearn dot, not skimage, but sklearn dot matrix import mean squared error. So let's find our mean squared error. And mean squared error is simply going to allow us to see that, what kind of an error are we getting? I mean, are the values good or bad? And these kind of things. All right. We can also have like some sort of a prediction score, which we can try out. But right now, everything looks okay. So next thing that we want to do is to use the train test split. Keep in mind that all of our feature data is in the variable call x. You can see the x is right there, the data sets, with all the one-hot encoded columns. And y is a predicted value. So because this is supervised learning, we are giving it the x values, which is our data set with all the features, and we are also giving it the answer key, which is y. Okay. So I'm going to call train test split and passing in x, passing in y, and passing in test size. We can pass in anything for test size. I'm going to say 0.2. 0.2 simply means 0.2 means 20%. So this means that if our data has 22,000 rows, then only 20% of those rows will be used for testing and 80% will be used for training. Now, there's no rule over here that it has to be 20%. You can do 70-30 split and all that stuff. And we're going to also say random state, and we're going to set it to 42. All right. So let's actually try to find out what that means. Train test split is a function, as I've already explained to you. X is all the features. These are the input variables. This can be, the mileage, one-hot encoded columns, the year, the name of the car, which is one-hot encoded columns. The y over here, y, is the target column, the price. The test size, I already told you, test size is basically how many rows are going to be used for testing, how many records are going to be used for testing. So 0.2 means 20%. And then we have the random state. Now this sets a seed for the random number generator. So the split is reproducible. And you can use any number you want, and 42 is just a popular number to use. Now keep in mind that it does return some stuff, right? I mean, it's going to return you a couple of different values. So when you call train test split, it's going to return you as 4 values: x train and x test, y train and y test. All right, in that order. So don't mess up this order. And the convention is whenever you type x, is usually it's a good idea to put it in a uppercase letters. So that's why X train and X test are in uppercase, or X is uppercase and Y is not. All right. Let's go ahead and run this. Okay. So it's already split the data. If you want to see what X-train looks like, you can say X-train dot, what would be like a count or something, dot length maybe. Oops, there's no length function. I wonder if there's a count function over here. Let's see over here. Okay, so X-train over here, you can see that this is 17,600 rows. Okay, so 17,600 for everything. So that's one of the things, right? Now you can also say X test. There are multiple ways to count these things. It's only 4,400. All right, so that means that it's only 20%. Basically, that's what I'm trying to say. All right. Next step, we have the data. We can go ahead and create linear regression now. So linear regression, I'm going to create an instance of linear regression and then train them. When you train, you call the fit function and you pass in the training data. X train, Y train. That's it. And it's training, and it's done. It's done pretty quickly, because it's all, CSV data. So that's why it was able to do it really quickly. Okay. Now another thing that would be a good idea would be to, look at the mean, square error or mean squared error. Okay. So let's go ahead and try to do that. So how do we do the mean square error? We have already imported the mean square error right there. And the good thing about mean square error is that it's going to tell us that how much the error we have and what is like a difference. Meaning, if I say Y predict over here, and I say model dot predict X test. Now we're passing in the test data set, and the reason we're passing test data set is that we're not going to pass in train because you don't really want to, perform the prediction on the training data set, the things that it has already seen. We don't really want to give it the things that it has already seen. We need to give it things that it has never seen, which is a test data set. When it splits it in a way that the data or the records in the test data set are not in the training data set. So it has already done the prediction, and now we have calculated the mean square error. All right, so we pass in the test. As you can see, I'm passing in the test over here, and I'm passing in the prediction. Okay. Now, keep in mind that you will really not be happy with, the result of this, and I'll tell you why. All right. First, let's go ahead and print this out. First, let's go ahead and see that what the mean square error is displaying. So I'm just going to go ahead and print it out. There we go. And let's go ahead and run the whole thing again. So I'm just going to go to run all, runtime and run all. Look at that number. That is an insanely big number, right? So what happened over here? So this means that the price of the car, the thing that we're predicting, can fluctuate, can have an error of this number. And this is like a huge number, like a really huge number, right? Wait, so what just happened? How did it even, how did it even do that? Well, the reason is these one-hot encoded columns. See that one-hot encoded columns? That is the problem. There are way too many one-hot encoded columns over here. And when you have like 200 or so, which I've been telling you, when you have so many one-hot encoded columns, then it doesn't work like that. I mean, it basically kills the whole algorithm, and that's why we're getting these kind of problems. Okay? So what is the solution for this? Well, the solution is don't use one hot encoded column when you have like a billion columns. That's a solution, right? So which algorithm can we use in this case? All right. So right now, if we look at our data, we have a lot of one hot encoded columns. And what we want to do, if we go back now, because now we have to trace back where we created those things. So what was the reason of doing all these things? Well, the reason was to show you that if we use one hot encoded columns and you have like 200 columns or so many columns, then your error rate will be very high. The fix in those cases should be not to use one hot encoded column. So I'm just going to go up and try to see if we can figure out that where we were using one hot encoded columns. So right over here, right? Right there. So what can we do with that? Well, instead of maybe using one hot encoded columns, maybe if we use something else, like label encoding, so that for each of this car, we will assign a unique number. So if there's a Honda Accord, we will assign 7. And if we see another Honda Accord, it will be 7 too. But then if we do that, we cannot use a linear regression because, again, the linear regression is going to say, oh, the Toyota Camry is assigned 128 and Honda Accord is assigned 7. So 128 is bigger than 7, so it has to be better. But that's not the case. These are just some label encoding that we have to do. All right. So let's see how we can fix this problem first. We have this df, we have x, so somewhere down the line, I think we have the value x or something, right? I think we have to kind of like go back trace where we were doing all this concatenation and stuff right there. You can see concatenation, and you can see over here name dummy columns and all that. Let's go up. Okay, so if I'm over here, okay, so this is already, you can see it's already kind of like changed because the df has already been assigned. So what we can do is we can somehow get our name column back, and then we can create a new label encoded column. So the easiest way for me was to simply delete all the lines which were creating those columns. Don't worry, I'll give you the code and all that stuff, but I've deleted those lines so that now we're starting again with the name column. All right. But we cannot really use the name column because the name column is string and we want to use a number because machine learning algorithms work really nice on numbers. So what we're going to do is we are going to again go back to Scikit-learn. We will import label encoder. Label encoder. Okay. And what the label encoder is actually going to do is assign a different label to each of these names. So now I can say df name encoded le, which is label encoder, fit transform, and the column that we want the label encoding, which is the name column. Okay, so what we have done is we've added a brand new column into our data frame, which is in label encoded column, and you can see right there. So this means the Chevrolet Trax is 71, GMC Terrain is 127, and if down the road in these names you see Chevrolet Trax, then it will always be 71. So once we have that, what we can do is create our x and create our y. So x is equals to df, and we need to get access to the data frame. So the data frame, if you want to return data frame, you just do it kind of like this. So year column, miles column, and not the name column, but the name encoded column. And then Y will be the simpler one. The Y will be simply the price column. Now, if I look at the X, it looks nice. Everything is in numbers. There's no name over here. We don't have a 301 hot encoded column, so we don't have that. But we're not going to use linear regression in this case. We will have to use something else. And one of those algorithms that you can use is the Random Forest Regressor. Now, you can research it a little bit more about what is Random Forest Regressor, all right? And it's basically a tree. So basically, if you have multiple friends, you can ask, you can ask your friends. Let me actually see if ChatGPT can help us out over here. Explain by diagram, by S-key diagram, Random Forest Regressor. So basically, it's going to, you can see it's decision trees. It's multiple decision trees. You're asking multiple of your friends that, hey, should I get this watch, Rolex watch or not? And one person will say, yeah, sure. And the other person will say, yeah, sure. And the third person, no, you know what, Rolex watch is not that good, don't get it. And then you kind of like, weigh in, you find the mean, how many people said, oh, you should get a Rolex watch versus how many people said you shouldn't get a Rolex watch. So, and then you perform the final prediction. So when you use random, forest regressor, the label encoding, it doesn't matter to it because it's a tree. Unlike linear regression, which is going to look at these name encoded values and it's going to say, oh yeah, 127. So this car is definitely better than the 71. But that's not the case. These are simply the encoded values. Again, we're going to use a train test split. We have already written that line of code, so I can simply copy that. Let's see over here, train test split. I'm not sure why it's complaining over here. Train test split is not defined. Okay, so maybe I have to import that. All right, and I have to import a couple of other things. Don't worry about that. Let's go ahead and import Random Forest Regressor and train test split. Next, we will go ahead and create our model, which is Random Forest Regressor. See, Random Forest does have a regressor, which can be used to find a single value, but it also have a classifier, which can tell you that, oh, if this person has diabetes or not, so classify things. Well, we are going to use a regressor, and we will pass in the n estimators, like how many trees you want to build. I'm just going to say 100. You can try with different numbers. Now, the higher the number, the more trees it will create, the more processing power it will need. Model.fit, xtrain, and ytrain. Let's go ahead and run this. It is going to take a little bit more time because we are passing 100. So you can see it took a couple of seconds, but at least now we have our model is trained. Next, we will import mean, absolute error, and R2 score. So this is going to give us an idea of how our prediction is. I'm going to say yPredict, model.predict, xtest. So we're going to pass in the test data set so that it can actually predict. And then we're going to compute the mean absolute error and also the score. And now finally we will print it out. Okay, that is much better than the last time. Remember the last time the score was like, it was like very, I mean, the mean absolute error was like insane. It was like millions and millions or something. So mean absolute error over here is saying that the price may be, there's a variation of $913, which is, it can be off by $913, all right? And the score for our model is 85%, 0.85 means 85%. So that's actually pretty decent score. You can always try different algorithms to get it to 90 and so. Sometimes it's based on the data and all that, but that's a pretty good score, okay? So that is pretty much it. I mean, this is a pretty long video, and you learn about, you know, that how to train your model, how to clean your model, and then we use the one-hot encoding. We ran into some issues, and then we started using the random forest regressor, and you learn a lot about. I mean, this is a real project with real data, real cleanup stuff, and everything real. Okay. So hopefully you have enjoyed it. Thank you so much, and I'll see you in the future video.